Hi everyone, this is Dr. Nak. Today what we're going to be talking about is graphs of linear functions. So let's first go with the definition. A linear function is a function of the form f of x equals mx plus b. The graph of a linear function is a line with slope m and y-intercept b. So this m is the slope and then b is called the y-intercept. Alright, now the domain of linear function is all real numbers. So in an interval notation, we write it as negative infinity to infinity. Functions that are not linear is called non-linear functions. So let's just review what the formula for the slope was. So slope is denoted by m. We call this delta y over delta x, meaning the difference of y over the difference in x. So which is y2 minus y1 all over x2 minus the x1. So if you remember what we talked about in the last section, slope is a number that measures the steepness and the direction of a line, which is also the key ingredients for the linear function. Now let's go with the definition of the y-intercept. Y-intercept is denoted by b, so it's this b right here. So what is it? So where the graph crosses or touches the y-axis, i.e. b is nothing but f evaluated at 0, which is same thing as the y value when x is 0. Now the x-intercept is where the graph crosses or touches the x-axis, i.e. the value of x when f of x equals to 0. So in this case, it's a value of x where y equals to 0. Okay, so suppose this is the graph, right? So where is the y-intercept? Well, let me just denote this by y and x. So the y-intercept is nothing but where the graph is going to cross the y-axis. So let's pretend that this is when y equals to 1. Let me just make this y equals to 2 and so forth. So notice that at the y-intercept, do you see that your x value is always going to be 0? That is always going to be the case for the y-intercept. Now x-intercept is pretty much the same thing, but x-intercept is where the graph is going to cross the x-axis. So let's just pretend this is 1 and maybe this is 2 and this is 3. So this point right here is when x is 2. Notice that at the x-intercept, your y value is always going to be 0 no matter what. So that's why it says b, which is the y-intercept, is the y value when x is 0, which makes sense. And for the x-intercept, it's the value of x when y equals f of x equals to 0, which makes sense. Okay, now what we're going to do is we're going to graph the linear function by using the slope and a y-intercept. So here are the steps. So step 1, find the y-intercept. So here's what you need to do. If you're given a function, set x equals to 0, and all you have to do is solve for y. And that y value is going to become your y-intercept. All right, step 2, find the slope. That's the rate of change of the input value. So it's the same thing as delta y over delta x. And step 3, plot the y-intercept on the graph. And step 4, perform rise over run to find at least 2 more points on the line. And finally, step 5, sketch the line passing through these points. Now for step number 4, your book wants you to find at least 2 more points on the line. All you need is after you plot the y-intercept in our class, just find 1 point on the line. That's good enough because in order for us to draw a straight line, all we need is 2 points. But anyways, let's do some examples. All right, example 1, graph f of x equals negative 2/3 x plus 5 by using the slope and the y-intercept. Okay, so let's first jot down what we need. All right, so if the equation is of this form, if it's f of x equals mx plus b, then your m is the slope and your b is the y-intercept. All right, so here our m is negative 2 over 3. And our y-intercept is, where is that? Y equals to 5. So this is where the graph is going to cross the y-axis. So let me just plot that. So the y-intercept is at 5, so I'm just gonna make a dot right here. Now from here, you're gonna have to perform rise over run to determine another point on the graph. So let's go back to our slope. Now, I purposely wrote this way. Notice that your negative is outside of the fraction. So in this case, if you're gonna do rise over run, you're gonna have to pick and choose where you're gonna throw this negative sign on. So you can do it this way. So if we prefer to toss that negative on the top, that's totally fine. So negative 2/3 is same thing as negative 2 and then over 3. Also, if you want to toss that negative sign on the bottom, that's fine too. So you're going to have 2 over the negative 3. The point that you're going to plot are different. However, they're all going to lie on the same graph, as you will see. I'll just do both of them. Okay, so let's first go with negative 2 over 3. So I'm going to take this one right now. All right, so if I'm going to do rise over run, then from this point right here, I need to rise negative 2. So that means I need to go down 2 units, and then run is positive 3. So you're going to have to go 3 units to the right. Now, after you perform rise over run, make yourself a dot. And here's that dot. And then after that, all you have to do is connect those 2 dots. And boom, there's your graph of f of x equals negative 2/3 x plus 5. All right, so this is the graph of f of x equals negative 2/3 x and then plus 5. Okay, now what we're going to do is let me take this slope. So suppose you toss that negative sign on the bottom. Okay, so now this is what's going to happen. Always start from the y-intercept. Now this is telling us to go 2 units above. Rise is 2, right? So I'm going to go 1, 2. And run is negative 3, so I need to move 3 units to the left. 1, 2, 3. Now, do you see that after I perform the rise over run, the point that we just got is going to be right here, which also lies on the same line. So if you're given negative out here, it doesn't matter which way you're going to toss your negative. You can either toss it on the top or toss it on the bottom. All right, so then let's take a look at another example. Example 2, graph f of x equals negative 2/3 x plus 5 by using transformations. Now, this graph is exactly the same thing as in example 1, but we're just going to graph it in a different way. Now, when you're going to graph by transformations for the linear equation, always start out with your first graph to be, let's just call it a y1 equals to x. So if you want to, you can just do it like this, x and a y, and make a little chart. So let's call it y1. Okay, so do you see that when x is like negative 2, y1 is also going to be negative 2. They're the same value. And then let's go negative 1, 0, 0, 1, 1, and then 2, 2. All right, so let me draw that mother graph. Oh, hey, that's not that bad looking. All right, so this is, let me just denote this. This is our y1, which is going to equal to y equals to x. So always start from here when you're going to have to use the transformations. All right, now for the second function, you can do however you want, but what I'm going to do is this. Let's just compress this graph by the factor of 2/3. So what I'm going to do is I'm going to graph 2/3 x. So in this case, you can do the same thing if you want, but notice that your x can stay the same, but your y value is going to be compressed by the factor of 2/3. All right, so let me just do this, x and then y2. All right, so let's just keep the same x values, right? And then your y value is going to change. All right, so when x is negative 2, your y2 is going to become 2/3 times the negative 2. So this becomes negative 4/3, which is same thing as, what is that, negative 1 and 1/3. All right, and then when x is negative 1, your y is going to become negative 2/3. And when x is 0, this is going to go to 0. When x is 1, this is going to become 2/3. And then when x is 2, this is going to become 4/3. Again, which is same thing as 1 and 1/3. X is -2, and then y is -1/3, right? So here's -1, and then 1/3 of the next grid will be, can you see this okay? It will be the 1/3 of the next grid. So maybe it's right over here. And for the next point, it's -1, comma -2/3. Now, -2/3 approximately -0.67-ish. So that will be, where is it? Like maybe here. That's good enough. All right, and then you're gonna have to go 0, 0. Okay, and then 1 and 2/3, so that's approximately 0.67. So you're gonna go 1, oh goodness, and 2/3, 0.67, like maybe right here. And when x is 2, our y value is 1 and 1/3. And I think that's about there. So now let's connect those dots. Okay, so here it is. That's good enough. Okay, so this is our y2, which we took the first graph, which is y equals to x, and then we compressed that by the factors of 2/3. So this is 2/3 x. Okay, now for the next one, I'm going to do it like this. So y3 is -2/3 x. You know what? Before we forget, let me just write this as compress y1 by the factors of 2/3. Okay, now let's go with the y3. So y3 is nothing but a negative of y2. So what's going to happen is that the blue graph, you're going to have to flip it over, which means that we're going to have a vertical reflection. So if you cannot just draw it immediately, just take it one step at a time. It's all good. So you got an x and then y3, right? Your x value is going to stay the same. So you're going to go -2, -1, 0, 1, 2. Okay, so it's going to be the -2/3 x, right? So you take the y values from y2 and then just change the sign. So this is going to be 1 and 1/3. And then this is going to be 0.67, 0, 0, 0, so it's good to go. And then this is going to be -2/3, and then -1 and 1/3. So plot these points if you want to do it step by step, and connect those dots and draw a line. That's good enough. So this is the graph of y3, which is -2/3 x. So let me write this down. So our y3, what we did was vertical reflection of y sub 2, the previous graph. Okay, almost there. So now let's go with the last step, right? So y4 is -2/3 x and then +5. So that means what? You take y3 and bring each point 5 units upward. So I'm going to write this as shift y3 by 5 units upward. All right. So what you need to do is you take all the y values that you got from your previous step, and then you add 5 to each of the y values. And those are the points that we're going to be plotting. So here you're going to have to go 1 and 1/3 plus 5. And if you want to make a chart like what we did earlier, that's totally fine. So your x value is going to, let's just keep them the same. And then let's go with our y4. So remember, you take the y values from y3 and then add 5 to each term. So I'm going to keep it as -2, -1, 0, 1, 2. Okay, so you're going to have to go 1 and 1/3, which is same thing as 4/3 plus 5, which is same thing as 4/3 plus 15/3. You have to get a common denominator, right? So this is 19/3. And what the heck is that? That's 6.3-ish. So I'm just going to approximate as 6.3. So let me just plot that before I forget. So when x is -2, y is 6.3. 3-ish. That's good. All right, so when x is -1, the y values from the previous step was approximately 0.67, and if I add 5 to that, this is going to be approximately 5.67. Okay, so when x is -1, 5.67, that's good enough. All right, now when x is 0, your y value was 0 for the previous step, and you just add 5 to it. Okay, this one's cute. All right, this one's just going to be 5. Oh gosh. All right, and then when x was 1, your y3 value was -2/3, right? And then you're going to have to add 5 to that. So this is same thing as -2/3 plus 5/1, but you're going to have to put the common denominator of 3, so you're going to have 15 on the top. So this is going to give us, what is that? 13/3. And that's approximately, what the heck is that? 4.3-ish. All right, so let me go. When x is 1, y is 4.3. Does that look all right to you? I think that looks good. All right, so now when x is 2, our y3 value was -1 1/3. So that's -4/3. And you're going to have to add 5 to that. So you're going to have -1/3 plus 15/3. So that's going to give us 11/3. I think that's approximately, what is that? 3.7-ish, I want to say. So let's plot that. So let me go with when x is 2, 3.7-ish. So here is our dot. Now connect those dots, and that is going to be our final graph. There you have it. So this is our final graph, which is y4. I'm just going to call that f of x is -2/3 x and then plus 5. So if you compare this with the graph that we drew from example 1, it should be exactly the same. And in this case, yes, it is. So we did it right. Okay, so for example 3, let's play a different game. I'm going to give you all a function, and what I want you to do is find the slope, x-intercept, and a y-intercept. So let's do a couple of examples here. Part A. Let's take f of x to be 3x minus 5. Okay, so I think this is already of the form f of x equals mx plus b. So we got ourselves a slope. Slope is 3, and the y-intercept is -5. So let me just write that out. So the slope, it's going to be +3, and the y-intercept is at y equals to -5. Okay, so that part is good. Now let's go with the x-intercept. Now, how do you find the x-intercept? Let me just write it out. What you need to do is you're going to have to set y equals to 0 and you solve for x. Because remember, at the x-intercept, your y value is always going to be 0, right? Because that's where the graph's going to cross the x-axis. So let's set y equals to 0. So remember, y equals to f of x. So we're going to have 0 equals 3x and then -5. Now add 5 to both sides. Then what we're going to get is, what is that? 3x equals to 5. So that implies that x is 5/3. Okay, so therefore our x-intercept is going to be 5/3. Let me just box everything here. So slope is 3. Y-intercept is y equals to -5, and then our x-intercept is going to be x equals 5/3. So here's the rough sketch. So y-intercept is -5, so this is our y-intercept. Slope is 3, which is same thing as 3/1, so you're going to go 3 units up and then 1 unit to the right. So that's going to be x equals to 1, and then if you connect those dots, this is the graph that I get. Now, the x-intercept will be right here when y equals to 0. So this point right here is, what do we get? 5/3. So let me just write it out. This is x is 5/3, y is 0, and then our y-intercept here is when x is 0 and then y is -5. You didn't have to graph it, but I just wanted to give you the visual of what you just computed. So this graph is also the graph of f of x equals 3x minus 5. All right, so let's take a look at another example. Part B, 7x plus 2y equals 56. So we're playing the same game. We want to find a slope, x-intercept, and a y-intercept. Now notice that this is not of the form mx plus b. By the way, we're going to have to notice it anyway. So this equation here, right, y equals mx plus b, this is called the slope-intercept form. All right. Now, if you have equation of the form ax plus by equals to c, this is called the general form. General form of the equation of a line. So here, you don't know what the slope is immediately. You will know the slope if you can put the general form into a slope-intercept form. So how are we going to do that? All you have to do is just solve for y from the general form. Okay, so ready? So what we're going to do first is let's keep the y on the left hand side and let's subtract -7x. All right, so then what do we get? We're going to have 2y equals -7x and then plus 56. Now we're going to solve for y, right? So you're going to have to divide it by 2. So if you're going to do that, you better divide everybody by 2. Okay, so in this case, you're going to have y equals -7/2x and then plus 56/2, which is just 28. Okay, so let me just box that because I need this to determine the slope. Okay, so here we got slope to be -7/2 and we got y-intercept to be 28. Okay, so now let's go with the x-intercept. So again, how do you get it? Is you're going to have to set y equals to 0 and you have to solve for x. So here you can do it two ways. So first of all, you can do the same thing as what we did in the part A. You can set this y equals to 0 and just solve for x. And the second method to do it is you just take the original equation and then you can set y equals to 0 and then solve for x. You should get the same answer. Okay, but let me just show you how to do it both way then. Okay, so let me just take the slope-intercept form and I'm going to set that y values to be 0. So here we're going to have 0 equals -7/2x and then plus 28. Now we're going to solve for x, so we're going to subtract by 28. Right, and then what do we get? You're going to have -28 equals -7/2x. Now how do you solve for x? You multiply by the reciprocal of -7/2, which is -2/7. You know what? Let me just make a little room here so that way you can follow my work. So let me just keep that as -28. I think this is what I had before, right? So now I'm going to multiply by the reciprocal of -7/2, which is -2/7. Then I'm going to have to multiply here by -2/7. Then on the right hand side, you're just going to have x equals, and this is going to be, so you have a negative times a negative, so it's going to become positive. So right now you have 2/7 multiplying here by, that's a 7. Goodness gracious, that's a 7. All right, and then 28 is same thing as 28/1. Before I multiply 2 and a 28, I think I can simplify a little bit. So 7 goes into 7 once, right? And then into 28 4 times. So it looks like our x-intercept is going to be 2 times 4, which is just going to be 8. So let me box that. And here is the slope, which is -7/2. Y-intercept is 28 and x-intercept of 8. Now let me show you how to find the x-intercept by using the general form. So let me make a little slash here so that you can follow my work. Okay, So now what I'm going to do is I'm going to take the original equation, which is in general form, and we're going to set our y to be 0. Ready? So if we do that, then what we're going to get is 7x plus 2 times 0 equals to 56. So this is just 7x equals to 56. Now what? Divided by 7. Then, boom, what do we get? X equals to, what is 56 divided by 7? 8. So we get to that same answer. So to me, for this particular problem, to find the x-intercept, I would have taken the general form instead of the slope-intercept form. But you can do whichever way that you like. All right, now let's play another different game. So example 4, given the graph, write the equation for a linear function. So here, our graph is given. So what the question's asking you is, what is the equation of this graph? So now the easiest way to do this is find the y-intercept, right? And then if you can find the slope from there, then we can form a slope-intercept form and be done with. And that is the method that we're gonna do. So ready? So this is our x-intercept. I'm just kidding, y-intercept. So the y-intercept is at y equals to 3. Now to find the slope, we're gonna remember how we got the slope before. We started from the y-intercept and we did rise over run, and then you made the final dot and then you connected those two dots to form a line. So here you have to pick a point, like a specific point that you have on the graph. So I'm just gonna pick this point because this point looks nice, because this point is when x equals to 2 and then our y equals to 7. So let me mark that. Okay, so what we want to do is we want to start from our y-intercept and then count how many units we went upward and how many units we moved towards the right. Okay, so here it looks like 1, 2, 3, 4. So our rise is 4. And then our run is positive 2. Okay, so I think we're good to go. Okay, so let me just write y-intercept. This is b equals to 3, right? And then it looks like our slope, which is m, is rise over run, which is 4 over 2, which is 2. Okay, so let me just box that. So now we have the slope and we have the y-intercept. So therefore, we can form the slope-intercept form. So it looks like our answer is going to be f of x equals, remember, mx plus b. Let me just write everything out. So this graph is 2x and then plus 3. So that is that equation of the graph. Okay, so now our next topic is to talk about a little bit about horizontal and vertical lines. So let's first go with the horizontal line. How do you think we're gonna write an equation of a horizontal line? Well, let's take a look. So I'm gonna make our x and a y chart. Again, you can pick and choose whatever the number that you want. Let me just take -2, -1, 0, 1, 2. Now let's compute the corresponding y value. Okay, so when x is -2, what's the y value? 3. And when x is -1, what's the y value? Oh, 3. When x is 0, your y value is 3. X is 1, y value is 3. So do you see that no matter what that x values that you're given, your y values are always going to be 3? Which means that your x value doesn't really matter, because no matter what, your y value is always going to be 3. So how do you write that? Well, only choice that we have is y equals to 3. Notice that that equation does not depend on x, because x doesn't matter. X can be anything, but the y value must remain 3. So if you're given the horizontal line, the equation of the horizontal line is always going to start from y equals the y-intercept value. So in this case, our y-intercept was 3. Now, let's do the similar thing for the vertical line. Okay, so here's our vertical line. Now, let's make a chart. Now, this part is going to be a little bit different because look, our x, what's the x-intercept? 1, 2, 3. So the x-intercept is 3, right? So in this case, no matter what, your x value is fixed. Your x value is just 3. So look at it in this way. When y equals to -2, is that -2? What's the x value? Well, 3. When y is 0, what's the x value? 3. So here, what you're doing now is that no matter what the y values are, your x values is always going to be the same. So in this case, x equals to 3. So again, vertical line does not depend on what the y values are. So how do we write that? Well, we're just going to write it as x equals to 3, and that's it. So to write an equation of a vertical line, every time it's going to start out with x equals, this value is going to be the x-intercept of the line. Now let's talk about the slopes of horizontal and vertical lines. Now there are 4 options for the graph of a straight line. So one of them is that the first one would be your graph is rising. All right, and then the second one is your graph is falling. And the third one is your line is horizontal. And the last one is you got yourself the vertical line. So this is what I was talking about. So this is the picture-wise. This will be the rising graph. When you read the graph, you always want to read it from left to right, okay? And then for here, if I read it from left to right, do you see that this graph is falling? And this one is horizontal or constant. And then here's your vertical line. So think of these as a road, you know? So here's your uphill, right? And then downhill, flat, and then, oh my goodness, this is like a cliff, right? So again, when you look at the graph, you're going to have to read the graph from left to right. So if I take the first line, I'm going to have to, pretend this is me, I'm going to have to start from the bottom, then climb upwards. Okay, so now for the next line, again, I'm looking at the graph from left to right, so I'm going to start from here. And in order for me to get to the right-hand side, I need to go down, which means that less energy is involved. Now let's talk about the horizontal line. Again, I need to look at it from left to right, so I'm going to start walking from here. Now, in order for me to go to our destination towards the right, well, I'm not climbing upward nor downward. So really, no energy need to be involved for me to walk the flat road. So I'm just going to write it as I don't need to put in any effort. So far, think of it in this way. So if I'm climbing upward, slope is positive. If I'm climbing downward, my slope is negative. If I'm walking on the flat road, my slope is 0. All right, now let's talk about the vertical line. So again, when you look at the graph, you're going to have to look at it from left to right, right? But there is no notion of going from left to right. So if I'm going to start from the top, I cannot go either left nor right. I have no choice but to fall down and then just die. I don't even know what kind of math I'm teaching you now. But anyways, in mathematical term, if you have a vertical line, we say that the slope is undefined. So the undefined slope is basically Dr. Nak has fallen off the cliff. Our next topic is to write an equation of a line in different forms. So let's first go with the general form. So if the equation of the line is in general form, if it is written as ax plus by equals to c, where a, b, and c are constants. All right, and the second one, the equation of a line is in slope-intercept form if it's written as f of x equals mx plus b. We have seen the slope-intercept form and general form earlier. Now, I think this one is kind of new to all of us. The equation of a line is in point-slope form if it is written as y minus y1 equals m times the quantity x minus x1. So please note that for the point-slope form, this y here and this x here remains as variables. And what's going to be the numerical values are the y1, the slope m, and then x1. Okay, so let's take a look at this equation. Y minus 3 equals 3 over 4 times the quantity x plus 1. Now, I just made that up. So this equation is an equation of a line in point-slope form. Now, what does it mean? Well, this means that this line has slope of 3 over 4. And also, at the same time, it's passing through the point. Let's just write it. Passing through the points when x is negative 1 and then our y is 3. Now, we can easily solve for y to get the slope-intercept form. So what I mean is this. So starting from point slope, we can rewrite this as y minus 3 equals 3 over 4x plus the 3 over 4. What I did was I just distributed this 3/4 to each term. Now, let's try to solve for y. Now, if I have to solve for y, I have to add 3 to both sides. Then we're going to have y equals 3 over 4x and then plus 3 over 4 plus 3 over 1. Now, as a side work, let's add these two together. So I'm going to write it as side work. So 3 over 4 and then plus, now 3 over 1, I need a common denominator of 4. That means that I need to multiply the top and the bottom of 3 over 1 by 4. So on the numerator, you're going to have 12 over 4. So if I add, you're going to have 15 over 4. So our slope-intercept form of the equation of the line is going to be 3 over 4x and then plus 15 over 4. So let me just box that and then box this. All right, so again, this is in the point slope form, and then this is in slope-intercept. Now, given the point slope, you can get slope-intercept. Now, from the slope-intercept, you should be able to get a general form. In order to get a general form, what you want is all the variables x and y on one side and just a constant term on the other side of the equal sign. Okay, so with that said, all we need to do is what? You're going to have to move 3 over 4x to the left-hand side by subtracting by 3 over 4x. So here, what we're going to get is negative 3 over 4x and then plus y equals 15 over 4. So now it is of the form of ax plus by, where b is 1, equals to c, where c is 15 over 4. So this form right here is called the general form. So notice that all the forms, right, they all look kind of different. Okay, but when you graph them out, they are all the same graphs. We're going to do more problems involving these forms later on. All right, our next topic is parallel and perpendicular lines. Okay, so let's first go with the definition. Two lines are parallel if the slopes of the lines are the same, i.e., if the first function, let's call it f of x, equals m1x plus b1, and g of x, to be the other function, equals m2x plus b2. So these two lines are going to be parallel if their slopes are the same. Also, parallel means that the two lines will never intersect each other. I did the best I can to draw the two parallel lines here, but notice that if they're parallel, they're never going to intersect, and the measurement of the tilt of the lines, two lines are exactly the same, which means that the slope are the same. So with that said, let's take a look at example number 5. Suppose the first line is given by 2x plus 3y equals to 6, and the second line is given by 4x plus 6y equals to 0. Are the first line and second line parallel? Alright, so now before we begin, let's check our knowledge. What form is this equation in? So this is ax plus by equals to c. So yes, this is in general form. They both are in general form. Okay, so now in order for us to determine whether the L1 and L2 are parallel to each other, we have to find their slopes. Now if the slopes are the same, then yes, they're parallel. Alright, so keep that in mind, and let's take the first line. So L1, let me try to find his slope. Okay, so in order to do that, we need to solve for y. So let me just write down the original equation. Okay, so try to solve for y. That means I need to move my 2x on the right hand side. So then here you're going to have 3y equals negative 2x and then plus 6. Now you need to solve for y, so you're going to have to divide the left hand side by 3. That means that you better divide everybody by 3. Alright, so it looks like our y is negative 2/3 x and then plus 2. So let me just box that. Now what form is this in? Well, what do you got? Slope, right? We got the slope, and then this is y-intercept. So this is slope-intercept form. But anyways, so the slope of the first line, so I'm just going to call it M1, first slope, is negative 2/3. Alright, so let me just box that too, because that's important information. Now let's go with the second line. Second line is 4x plus 6y equals to 0 in general form. Solving for y, I'm going to subtract 4x. Then you're going to have 6y equals to negative 4x. So dividing by 6 on both sides, then what do we get? Y equals negative 4x over 6, which is the same thing as negative 2 over 3x. Now, can you tell me what the y-intercept of this line is? Somebody guess? Yes, the y-intercept in this case is y equals to 0. So because negative 2/3 x is same thing as negative 2/3 x and then plus 0. But anyways, so let me just box this. I'm not going to box the 0. Now let's call this slope second slope. What do we got? You have negative 2/3 again. So in this case, since M1 and M2 are the same, yes, two lines are parallel. So I'm going to write it as therefore. So I'm going to write it as M1 equals to M2. Therefore, two lines are parallel. I can't even write anymore. I meant to write two lines are parallel. Now let's talk about the perpendicular lines. So we say that the lines are perpendicular if the slopes of the lines are the negative reciprocal of each other, i.e., if f of x has slope m1 and g of x has slope m2, they're going to be perpendicular. The two lines are perpendicular if m1 equals to negative 1 over m2. Or if you want to check, you multiply the two slopes together. If that's going to equal to negative 1, then yes, two lines are perpendicular. So let's take a look at example 6. Suppose L1 is, first line is x plus 3y equals to 6, and the second line is 3x minus y equals to 5. Are the two lines perpendicular? So again, key to doing this problem is to find their slopes. So let's first take L1, which is the first line, is given by x plus 3y equals to 6. So just solve for y. So then what do? You're going to have to subtract x. Then you're going to have 3y equals negative x plus 6. And then you're going to have to divide it by 3. That means you better divide everybody by 3. So you're going to have y equals negative 1/3 x and then plus 2. Alright, so let me just box this because I need this equation. Now this is in slope-intercept form, and then our m1 is negative 1/3. All right, keep that in mind. Now let's go with the second line, L2. 3x minus y equals to 5. All right, so then subtract 3x. Then what do we get? Negative y equals negative 3x and then plus 5. Now dividing by negative 1 to each term, negative 1 divided by negative 1, negative 1. So then what do we get? You're going to have y equals negative over negative makes a positive. So you're going to have 3x. And then you have a positive 5 divided by negative 1. So this is going to become negative 5. So let me box that. Now in this case, our second slope is 3. Okay, now in order for us to check to make sure that they're perpendicular, you can just multiply them together, which means that, let me check. So m1 times m2. So this is negative 1/3. Multiplying here by 3. So this is going to become negative 1. So that means that, therefore, L1 and L2 are perpendicular to each other. Now, at the definition, it says that the two lines are perpendicular if their slopes of the lines are the negative reciprocal of each other, right? So we just determined that these two lines are perpendicular. So here's our first slope, second slope. Now, let's take negative 1/3. Okay, now what's the reciprocal? I didn't say negative. What is the reciprocal of negative 1/3? That's just negative 3/1, which is just negative 3, right? Now, negative reciprocal of negative 1/3 is going to be negative of the negative, so which becomes positive, and you reciprocate 1/3, so which is going to become 3. So in this case, the negative reciprocal of negative 1/3 becomes positive 3. Anyways, let's take a look at the next example. All right, example 7. Determine whether the lines are parallel, perpendicular, nor neither. All right, so let's do this. This is going to be fun. Okay, so again, what we need to do is we have to find the slope of each lines, right? So let's take the first one. So let me take 3y plus 4x equals to 12. And then let's just solve for y. So how do I do it? Subtract 4x from both sides, and you're going to have 3y equals negative 4x plus 12. And then you're going to have to divide it by 3. So then here, what we're going to get is y equals negative 4/3 x and then plus 4. All right, so let me just box that because I need this equation. All right, so now let's take a look at the second equation. The second equation is negative 6y equals 8x plus 1. So dividing by negative 6 each term, then what do we get? You're going to have y equals negative 8/6, which is the same thing as negative 4/3x, and then minus 1/6. So let me box that because they're important. Okay, now let's talk about that. What's the slope of the first line? That's negative 4/3. What's the slope of the second line? Negative 4/3. So what can you conclude? Yes, they are parallel because their slopes are the same. Okay, so I'm just going to write it as m1 equals to m2. Therefore, two lines are parallel. There you have it. Now let's go with example 7b, part B. So you're given y equals 2/3 x plus 1 and 3x plus 2y equals to 1. So the first equation, we don't have to do anything because that's already in slope-intercept form. But we still have to work on the second equation. So let me just write 3x plus 2y equals to 1. So let's work it. Solving for y, then I'm going to have to subtract both sides by 3x. Then you're going to have 2y equals to negative 3x plus 1. Now divide every term by 2. Then what do we get? Y equals negative 3/2x and then plus 1/2. All right, let me box that. Okay, so now let's determine the slope of the first line, which is y equals 2/3 x plus 1. So first slope is 2/3, right? And then let's go with the second slope. This is -3/2. So look at it. What is the negative reciprocal of 2/3? Well, you're going to have to toss the negative first, and then you're going to have to take the reciprocal of 2/3. So this is 3/2. So the negative reciprocal of 2/3 is -3/2, which is just our M2. So we know that they're perpendicular to each other. Now, if you don't want to think of in terms of a negative reciprocal of each other, then you can always check M1 times M2. So let's go. M1 times M2 is 2/3 times by -3/2. So 3 goes into 3 ones, 2 goes into 2 ones. So our answer is just going to be -1. All right. So therefore, two lines are perpendicular. How you all doing? Hopefully you're doing okay. So far so good. Please let me know if you have any questions. All right, so let's take a look at the next example. Part C. All right, the first line is passing through the point 1,7 and 5,5. The second line is passing through the point -1, -3 and 1,1. The question is, are those two lines parallel, perpendicular, or neither? So what do you got to do? You got to find the slope. So let's go with the first slope. So let me denote by M1 is the slope of the first line. So let me just write down the formula. So that's y2 minus y1 divided by x2 minus the x1. Again, it does not matter which one you want to call it, x1 or x2. As long as if you're going to pick the first ordered pair to be x1, then the y value of that should be y1. But anyways, so let me just go like this. I'm just going to take, so let's take this as x1, y1, and then maybe x2, y2. Okay, so I'm going to plug and chug. So here you're going to have y2 minus y1, which is 7, divided by x2, which is 5, minus the x1, which is 1. So here you're going to have, what is that? -2/4. So it looks like the slope of the first line is going to be -1/2. Let me box that important information. Now let's do the same thing for the second slope. So I'm just going to call it y2 minus y1 over x2 minus x1. Make sure to write down the formula each time. Okay, so then here, what do we get? 1 minus -3, whole thing over 1 minus -1. Be careful with that double negatives. All right, so this means that this is 1 plus 3 over 1 plus 1. So this is going to be 4/2, which is going to give us 2. Can you tell me the answer already? So first slope is -1/2 and the second slope is 2. What's the relationship? Yes, they're perpendicular, right? Because look at it. 2, the negative reciprocal of 2 is -1/2. Or you can just go like this, M1 times M2. So this is just -1/2 times 2, which is going to give us -1. So therefore, the two lines are perpendicular. I'm just going to write it as perpendicular. Perpendicular. Goodness. All right. I hope you're kind of getting the hang of it. Now let's look at part D. Pretty much the same thing. So the first line is passing through 2, 5, and then 5, -1. So you plot those 2 points and then connect those dots, and that's your first line. All right, now the second line is passing through -3, 7 and 3, -5. So again, plot -3, 7 and plot 3, -5, then connect those dots. That's your second line. You can kind of give yourself a rough sketch to see what's going on. But anyways, let's just do this mathematically. So first slope is going to be y2 minus y1 over x2 minus x1. Right, so that's going to be negative 1 minus 5 over 5 minus 2. So this is negative 6 over 3. So this is negative 2. So that's the slope of the first line. Now let's go with the second line. So the second line of the slope can be determined by y2 minus y1 over x2 minus x1. So this is negative 5 minus 7 all over 3 minus, be careful here, it's going to be minus 3. All right, so this is going to give us negative 12 all over 3 plus 3, which is 6. So this simplifies to negative 2. So what is our conclusion? You're correct. Since two slopes are the same, two lines must be parallel. Okay, so I'm just going to write it as m1 equals to m2. So that implies that two lines are, so therefore they are parallel. All right. Hopefully you all are getting hang of it. And if you got those all four of them correctly, good job. All right, so now let's take a look at the next example. All right, example 8. It says, write an equation of a line parallel to f of x equals negative 5x minus 3 and passing through the point 2 comma negative 12. So let's first understand visually what's going on. All right, so here is the graph of f of x equals negative 5x minus 3. Now, what we want to do is this. We want to come up with an equation of a line that is going to be parallel to this line. But at the same time, that new line better be passing through the point 2 comma negative 12. So this point right here is 2 comma negative 12. And from this point, I want to draw a straight line through this point, and then that's going to be parallel to our f of x, which is the green line. All right, so pretend that line is passing through 2 comma negative 12. You know what I can do? I'm just going to make this stuff fatter. There you go. Now the point is on the line. All right, so now I know they're kind of close to each other. So the game is this. I want to come up with the equation of this line. What is the equation of this line? And that's what the question's asking. All right, so let's start. Okay, so first thing, two lines are parallel if they have the same slope, right? So the slope of our new line better be negative 5. All right, and at the same time, it's passing through the point 2 comma negative 12, correct? So what are you given? Well, we have point and then the slope. We have a point and a slope, so we should be able to bust out the point slope formula. Let me write that out, which is y minus y1 equals m times the quantity x minus x1. Now we already determined our m. Now who's going to play the role of x1 and y1? What do you think? Yes, your x1 is going to be 2, and then y1 is going to be negative 12. All right, so now let's plug and chug and see what we're going to get. So we have y minus y1, which is negative 12, equals negative 5 times x minus 2. All right, so this means that you're going to have y plus 12 equals negative 5 times x minus 2. Great. Okay, so that is already an equation of the line, of the red line. Okay, but just to see it better, let's put this in the slope-intercept form, meaning solve for y. Okay, so we got this already. So first, what I'm going to do is I'm going to distribute the negative 5 in. So let me just go like this. So you have y plus 12 equals, distributing the negative 5 to each term, you're going to have negative 5x and then plus 10. Now subtract 12. from both sides. Then what do we get? Y equals negative 5x and then minus 2. So let me box that because this is the equation of the line that we want. So does it make sense? All right, so let's first check. Is our slope negative 5? Yes, because it better be parallel to our f of x, right? That makes sense. Now, this is telling you that the new line better be passing through when y equals the negative 2 because negative 2 is the y-intercept. So if I look, there it is. This line is passing through y equals to negative 2. So it makes sense. All right, so let me just, I know it's really hard to see. Sorry about that. There you go. So there you have it. Our answer is y equals negative 5x minus 2. So that is the equation of our red line. Okay, so then let's take a look at example 9. Write an equation of a line that's perpendicular to 3x minus 2y equals to 10 and passing through the point negative 5, 4. So step 1, you have to find the slope of the given line. And then we're going to have to find the negative reciprocal of that slope to find the slope of the new perpendicular line. But anyway, so let's start from our original equation and let's try to solve for y so that way we know what the slope is. So let me start out 3x minus 2y equals to 10. So then I'm going to subtract 3x. Then you have negative 2y equals, what do we get? Negative 3x and then plus 10. Divided by negative 2. Divided by negative 2. And then what do we get? We're going to have y equals positive 3 over 2x and then minus 5. So let me just box that because this is the equation in slope-intercept form. So all we did was we took this general form, we solved for y, and then made that into a slope-intercept form. So notice that our slope of the given line, let's just call it the first slope, is 3 over 2. All right, now the negative reciprocal of m1, let's just call that m2. So the negative reciprocal of 3 over 2 is negative, first of all, 2 over 3. So this is the slope of the perpendicular line that we're looking for. So let me write down what we got. So our first perpendicular slope better be negative 2/3. And then at the same time, it better be passing through negative 5, 4. All right, so always start out with the point slope form because look, you're given a point and a slope, right? So let me just write that out. Y minus y1 equals m quantity x minus x1. All right, so this one is, you can think of it as this is m2 if you want to be really nitpicky. So our x1 is negative 5 and then y1 is positive 4. All right, we got this. Let's do it. So you're going to have y minus y1, which is 4, equals the new slope, perpendicular slope, which is negative 2/3 times x minus x1. So you're going to have x minus minus 5. All right, looking good. So you have y minus 4 equals negative 2/3 times x plus 5. So this is the equation of the line that is perpendicular to 3x minus 2y equals to 10. But let's try to make that into a slope-intercept form. So again, we solve for y. So we're going to have y minus 4 equals, now distribute the negative 2/3 to each term. So you're going to have negative 2/3 x, and then you're going to have a minus 10 over 3. Now add 4 to both sides. Then what do we get? We're going to have y equals negative 2/3 x, and then you're going to have a minus 10 over 3 plus 4 over 1, right? But you need a common denominator of 3. So what you need to do is multiply the top and the bottom by 4 over 1, 2, 3 over 3. Multiply that by 3 over 3. And then what do we get? So this portion is going to become, I'm trying to do this step by step, negative 2/3 x, and then minus 10 over 3, and then plus 12 over 3. So let me just bring it over here. Sorry, I'm running out of room now. So we have y equals negative 2/3 x, and then now you have a negative 10/3 plus 12 over 3. So here you're going to have plus 2 over 3. All right, so guess what? This is our answer, which means that this this line, y equals negative 2/3 x plus 2/3, is perpendicular. It's going to intersect the given line in 90-degree angle. So let's take a look at these two lines. All right, so I've already graphed it out on the graphing calculator. So this is the two lines that we're talking about. Now our given line, which is 3x minus 2y equals to 10. And then remember, we solved for y and to get into the slope-intercept form. So that will be this line right here. Does it make sense? Is the y-intercept at negative 5? Yes, it is. And then if I perform rise over run, can I get to another point that's on the line? Ready? Rise is 3, 1, 2, 3. Over 2? Yes. Okay, so this line is perfect. Now, the equation of the new line that we got is y equals negative 2/3 x plus 2/3. So I graph this out, and then that is precisely this black line. Notice that, yes, they do intersect in 90-degree angle. So that's what you just computed. Given 3x minus 2y equals to 10, that's this line right here. You wanted to come up with the new line that's perpendicular to it. And this line is denoted by y equals negative 2/3 x plus 2/3. How you all doing up to here? I know it's a lot of work, it's a lot of memorization, all those 3 different forms of the equation of the lines, but you can do it. Write those out on a separate sheet of paper. Okay, so let's take a look at example 10. Write an equation of a line which has an x-intercept at x equals to negative 2 and y-intercept at y equals to 4. Let's give a rough sketch. Okay, so x-intercept at x equals to negative 2. So that's here. And y-intercept at y equals to 4. So what we're looking for is the equation of that line. Now remember, at an x-intercept, your y value is always going to be 0. So this point is negative 2, 0. And the y-intercept, your x is always going to be 0. And then y is at 4. Now, if you have 2 points, then you should be able to come up with our key ingredients to write an equation of a line. That's a slope. So let's first get the slope, which is y2 minus y1 over x2 minus x1. It does not matter which one you want to call it, the first ordered pair or the second ordered pair. But let's just, so that we all do it the same way, let's pretend this is our x2, y2. And then maybe this is x1, y1. All right, so then let's plug it in. So you're going to have 4 minus 0 all over x2, which is 0 minus x2 minus x2. No, this is x2 minus x1. I'm sorry. And then here you're going to have 0 minus 2. So this is 4 over positive 2. So slope is going to be 2. Let me box that because this is the key ingredient. Now from here, there are a couple ways that you can do. As you've seen before, right? Given the point slope form, which is y minus y1 equals to m times the quantity x minus x1. Do you remember that given that, you can come up with the slope-intercept form and also the general form? But here, you can start out with that if you like. Or, since in this case, you are already given the y-intercept and we just determined the slope, you can just bust out the slope-intercept form because we got the slope, we got the y-intercept. So that's the route that I'm going to go with for this particular problem. So I have y equals mx plus b, and then I know that our m is 2, and the y-intercept, which is b, is 4. All right, so if I plug that in, we're going to have y equals 2x and then plus 4. And that's going to be our answer. Alrighty, now let's look at example 11. Is this too many examples? I'm sorry, I'm like all the way up to example 11 already, but I feel that more problems that you see, better you're going to get at. But anyway, so let's take a look at this one. Write an equation of a line passing through the points -3, -4, and 3, 0. All right, so let's get started. All right, so let's just try to understand what we're doing. So the equation of a line that's going to pass through -3, -4, so that will be here, -3, -4, and then 3, 0. Here is 3, 0. So what we're trying to do is trying to come up with the equation of this line. Again, pretend that this dot is touching it's on the line. There you go. Just make the dot fatter as always. Okay, so ready? So what's the key ingredient? Slope. So let's do it. So our slope is y2 minus y1 over x2 minus x1. All right, so in this case, let me just, what do you all want to call it? So let's call this one x1, y1, and then x2, y2. Okay, so if I do it that way, then you're going to have y2, which is 0, minus y1, which is -4. And then all over x2, which is 3, minus x1, which is -3. So what do we get? We're going to have a positive 4 over 6, which is 2/3. So that is going to be our slope. Now, it's a little bit different than example 10 here. I want to go with, just the slope-intercept form, y equals mx plus b, but I don't know what my y-intercept is. So in this case, start out with the point-slope form. Point-slope form is the queen of the equation of the line. If you have the point-slope, you can derive slope-intercept, nor the general form. Let me write out the formula. So the point-slope is y minus y1 equals to mx minus x1. Now, here is what's very, very important. Yes, I know this is y1, x1, so you automatically assume that, oh, I'm going to take this ordered pair because I call that x1, y1. But guess what? It does not matter which ordered pair that you're going to take. Yes, the point-slope form is going to look completely different depending on which points that you're going to take. But if you solve for y equals mx plus b, your result will be exactly the same. And I will show you that. Okay, so let's first take the ordered pair of -3, -4. All right, so then if I plug it in, you're going to have y minus y1, which is -4, equals m, which is 2/3, times x minus x1, which is going to be -3. Clean it up a little bit, so you're going to have y plus 4 equals to 2/3, and then x plus 3. All right, now let's solve for y. Make that into a slope-intercept form. So what do? You have to distribute. Let me just do this step by step. You have to first distribute the 2/3 to each term. Then you're going to have, that's a 2, 2/3 x, and then plus 2/3 times by 3 is just 2. And subtract 4 from both sides. Then you're going to have y equals 2/3 x, and then minus 2. All right, so this is in slope-intercept form. And then this is in point-slope form. All right, now we're done with the problem. Yes, I know, but let me just show you that I can still plug it in 3, 0 in point-slope form. All right, and I could still come up with the same result in terms of a slope-intercept form. So let me do that. Okay, so that you will see it. Let me now pick 3, 0. All right, so now we're going to put this in the point-slope form, which is y minus 0 equals to m, which is 2/3, and then x, and then minus 3. Now take a look. So this is the point slope form by plug it in 3, 0, point slope. So notice that, look at the difference between the 2 point slope forms. They look completely different, right? But they're going to end up being the same. So let me just make this into a slope-intercept form now by solving for y. So what do we get? So we have y minus 0 is just y equals distributing the 2/3. You're going to have 2/3 x, and then what are you going to get? Minus 2 again. So notice that slope-intercept form, no matter which ordered pair that you're going to take, is exactly the same. Turn out to be exactly the same. I can't even write right now. Slope-intercept form. All right. But anyways, I just wanted to let you know that part. All right. Hang in there. So this is going to be the last topic of this section. Yes. Right. I know. Okay. So we're going to talk about the point of intersection between two lines. Okay. So here I have f of x equals negative x plus 5, g of x to be 2/3 x. What we want to do now is this. Where do they intersect? What is this coordinate x comma y is going to be? All right. So think about it. First, notice that the point lies on both lines, right? F of x and then also g of x. That's the only common point that they have. So what we need to do is this. To find the point of intersection, you're going to let f of x equals to g of x, then you just solve for x. So let me write that out. All right, so to find the point of intersection, step 1, set f of x equals g of x and solve for x. Then step 2, compute the corresponding y value by using either f of x or g of x. Your y value will be exactly the same whether you take f of x or the g of x. All right, so let's do one last example. Example 12. Find the point of intersection between two lines. F of x equals 3x minus 4 and g of x equals 5 minus x. All right, so here are the two graphs, f of x and g of x. Can you tell which is f of x and which is g of x? Think about it. F of x, so your slope is positive, so you better have a rising line. And g of x slope is -1, right? -1x. So that means that our red curve, not curve, what do I keep calling curve? Red line is your g of x. So I'm going to denote this as our f of x equals 3x minus 4. And then this one is our g of x equals to 5 minus x. All right, so step 1, what do we need to do? Set f of x equals to g of x. So if I do that, then you're going to have 3x minus 4 equals 5 minus x. And then from here, you solve for x. So let's bring all the x's on one side. So I'm going to add x to both sides in this case. So here you're going to have 3x plus 1x, so which is going to be 4x minus 4 equals to 5. Now I'm going to add 4 to both sides. Then you're going to have 4x equals to 9. Now dividing by 4. So here our x coordinate is going to be 9 over 4. Which is, what is that, 2.25? I believe so. All right, so now let's compute the corresponding y value. So to compute the corresponding y value, I think that I call that one step 2, right? It does not matter which function that you're going to take. Pick the cute one. To me, 5 minus x looks way cuter than 3x minus 4. So I'm going to plug 9 over 4 in place of x for g of x to compute the corresponding y value. So let's go. So I'm going to compute g of 9 over 4, which is 5 minus 9 over 4. All right, so that's same thing as well. We need the common denominator of 4. That means that I need to multiply top and the bottom of 5 by 4. So the new numerator is going to be 20. So what do we get? 20 minus 9 is 11 over 4, which is 2.75. All right, so this is the corresponding y value when x is 9 over 4 or 2.25. Okay, so let's see if that's gonna make sense. You know what? Make sure to write that in ordered pair. So therefore, the point of intersection is 9 over 4, comma, 11 over 4. So this is gonna be your final answer, is this one here. All right, so let's see if it makes sense. So the point of intersection is here. Okay, so at this point here, let me see. Our x coordinate, does it look like 2.25 to you? Yep, it looks good to me. And then your y value is 2.75. So 2.75, 2 1/4, it's here. All right, so yeah, it makes sense. So this point here is 9 over 4, comma, 11 over 4. Yay, we're done with this section. Yes, we did a lot of examples, and I know we went over a lot of things. So first thing first, good job. And second thing, write down all the formulas that you've learned in this section on a separate piece of paper and just keep it handy. Once again, good job, y'all. And if you have any questions at all, you know where to find me.